All right, so I'm going to go over the MVT, IVT, EVT quiz. Mostly it's going to be MVT and IVT here. But we have a differentiable function. So we don't know that the function is continuous yet. You have to justify that the function is continuous because the function is differentiable. So in part A, whenever we're looking at a value of r on negative 3 to 2 such that f of r is equal to 0, we have to prove that the function's continuous first. So you have to tell me that f is differentiable on negative 3 to 2, therefore continuous on negative 3 to 2. There exists a value r from negative 3r to 2 such that f of r is equal to 0 because f of negative 3 is equal to 8 and f of 2 is equal to negative 4. And this is where a lot of us aren't doing this part, which means that you did not get your full credit. You have to show the inequality. Whether you say negative 4 and 8, negative 4 is less than 0 is less than 8, or you say f of 2 is less than f of r, which is less than f of negative 3. Now, a lot of you guys gave me negative 4 is less than 0, which is less than 8, but you did not give me where you found these values. AKA, you needed to give me this and this. If you only gave me this right here, you would not earn full credits because I don't know where you're getting negative 4, and I don't know where you guys are getting 8s from. So make sure that you give me this, this, and this, and tie everything together by IVT. 1 point is giving me differentiable, therefore continuous, and then 1 point is for the IVT. Part B is asking us to find the value of g double prime of 1.5. So this is just going to be the average rate of change. So g prime of 2 minus g prime of 1, 2 minus 1. G prime of 2 is negative 6. G prime of 1 is negative 3. 2 minus 1. That gives us negative 3. So g double prime of 1.5 is negative 3. So that's 1 point right there. The other point is telling me what's happening about the graph of g. Not the derivative of g, not the slope of g, but the graph of g. So the graph of g is concave down. Now, I didn't take off if you didn't give me a justification, but get used to saying why something's happening. So the graph of g is concave down because we know that the second derivative is less than 0 at 1.5. So that would be another point right there. Part C is just a unit 2 review. So write the equation of the tangent line. H prime of x is equal to chain rule. So 2 times f of x times f prime of x plus g prime of x. A lot of us either forgot to do g prime of x or you guys forgot chain. Now, if you guys got this, a lot of us gave us 2 instead of negative 2. You needed negative 2. So looking at the table here with negative 2, I know that f of negative 2 is 3. I know that f prime of negative 2 is negative 2. And I know that g prime of negative 2 is 2. So I'm just going to plug that in. 2, 3, negative 2, plus negative 2, or plus positive 2. And then that's going to give us negative 12 plus 2, or negative 10. Now, because you're trying to find the equation of the tangent line, you need to figure out what h of negative 2 is. So you need to plug in h of negative 2. So f of negative 2 is 3. 3 squared is 9. G of negative 2 is 3. So that gives us 12. Form everything, so you'll get y minus 12 is equal to negative 10, x plus 2. 1 point is for giving me the derivative, or giving me, probably the derivative, so giving me the derivative. 1 point is giving me the value of h of negative 2, and then 1 point is giving me the correct tangent line equation. Now, for part D, this is going to be mean value theorem, so you need to justify that the function is differentiable and continuous, but remember that you cannot say and, you have to say therefore, because the condition for, because if the function is differentiable, then you know for a fact that the function is continuous. So f is differentiable on negative 2 is less than c, which is less than 2. Therefore, continuous, well, this is not f, this is h, sorry. H is differential. So also make sure that you guys are using the variable that they give you. Okay. Let's see. So then, there exists a value c from negative 2 to 2 such that h prime of c is equal to 0, since, and then this is the part where you have to justify your answer. They literally gave you the interval, use it. Now, this is also the part where you need to figure out what h of 2 is, because you already know from part C that h of negative 2 is 12. So h of 2 is f of 2 squared plus g of 2. F of 2 is negative 4. Negative 4 squared is 16. G of 2 is negative 4. So that gives us 12. So we have 12 minus 12 over negative 4 is equal to 0 over negative 4, which is equal to 0, which is equal to h prime of c. So notice how I connected everything, but there aren't any linkage errors because it's all the same thing. This right here is the same thing as this, which is the same thing as this, which is the same thing as this, which is eventually what we want because we want h prime of c to be equal to 0. 1 point is giving me the conditions, and then the other point is telling me all of that jazz by MVT. Now, one thing about the AP exam is that you don't necessarily have to say MVT and you don't necessarily have to say IVT, but if you do say a theorem, that theorem needs to be correct, or else you won't get full credit. So for example, if you accidentally said EVT here and you did all of the right work, you'll lose a point. Same thing here, if you did all of the correct work, but you accidentally said IVT, which is a wrong theorem, then you'll lose a point. All right, so make sure that you guys practice IVT, EVT, and MVT, because that's going to be very important on the AP exam and on the test.